So, you're thinking about learning to code. You've probably heard the name Python thrown around a lot. But why? What's the big deal? Well, today, we're not just going to talk about Python, we're going to draw you a map. This is your roadmap, taking you from the very first, simplest step all the way to building some seriously cool stuff. Let's get started.
So what can you actually build with this? How about your very own video games? Yeah, I'm serious. Using a library called Pygame, you can create whole 2D worlds from scratch. You could build a game where your character dodges asteroids, all based on your key presses and mouse clicks. That's totally within reach with Python.
Or, hey, maybe games aren't your thing. Maybe you're into data. Well, Python is an absolute beast when it comes to data science. With tools like Matplotlib and Plotly, you can take just a bunch of raw numbers and turn them into these beautiful, interactive charts that tell a story. You could visualize anything from stock market trends to weather patterns.
And it doesn't stop there. Python is also huge on the web. Using a framework like Django, you get all the tools you need to build your own web applications. I'm talking a personal blog, a portfolio site, even a little online store. And then you can put it online for the whole world to see. But here's the real secret, and this is important. The games, the charts, the websites, they're kind of like the Trojan horse. The real goal here isn't just to make a thing. It's to learn a new way of thinking. It's about learning a process for solving problems that blends logic, creativity, and a real focus on doing quality work. That's the superpower we're really building.
All right, so where does a journey like this even begin? Well, with a single step. And for Python, that first step is surprisingly simple. We're about to go from knowing nothing to writing your very first, fully working program in just one line of code.
And that's it, right there. Believe it or not, this is a complete Python program. That print command is you talking directly to the computer. You're just telling it, hey, display whatever I put inside these quotes. When you run this, Hello Python World pops up on the screen. You just gave the machine an order, and it obeyed. That's coding in a nutshell.
Okay, but to do anything really useful, our programs need to remember stuff. And for that, we use variables. Now, don't let the technical names scare you. A variable is just a box. You put some information inside it, like a piece of text or a number, and then you slap a label on the box so you can find it again later. Simple as that.
Let's see it in action. Here, we've made a box and we labeled it message. Then we put our Hello Python World text inside. Now, when we want to print it, we don't have to type the whole thing out again. We just tell the computer, hey, print whatever's in the box labeled message. The result looks the same, but this is a huge leap forward. Our info is now stored and reusable.
Okay, so we've got variables, we have our boxes, but you're going to find out pretty quick that one box isn't enough. What happens when you have a bunch of related information? You need a way to keep it all organized.
Python gives us two awesome tools for this: lists and dictionaries. A list is exactly what it sounds like. It's just an ordered collection of items, like a shopping list or a to-do list. A dictionary, on the other hand, is all about connecting things. You know, like how a real dictionary connects a word to its definition, a Python dictionary connects one piece of info, a key, to another, a value.
Check this out. Here's a perfect example of a list. We've made a list called magicians that just holds a few names. They're kept in that specific order, and it's a super clean way to keep a bunch of related items all bundled together. Now, look at this. This is a dictionary. See how it's different? It's not just a sequence. It's made of pairs. We're connecting a key, like the name Jen, to a value, the language Python. This is crazy useful when you need to store related data, like, say, a user's settings on a website.
So, we have our data. It's stored in variables, organized in lists and dictionaries. Now for the fun part, making the computer actually do something with all that information.
You know, one thing computers are amazing at is repetition. If you want to do the same exact thing to, say, 100 items in a list, you don't want to write that code 100 times. No way. You use a loop. A for loop basically just says, hey, for every single item in this collection, one by one, I want you to run this specific piece of code. Got it?
Let's go back to our list of magicians. This for loop will grab Alice first, and it'll run the print command for her. Then it'll grab David and do the same thing. Then Carolina. Now that little bit of empty space, the indentation, that's not just for looks. In Python, that's how you tell the computer what code is inside the loop. It's super important.
But good programs don't just repeat things. They have to be smart. They need to make decisions. And that's exactly what an if statement is for. It's just a test. The code here asks a simple question. Is the value in the age box greater than or equal to 18? In this case, yep, It is, so the message gets printed. If age was 17, the computer would see the answer is false and just skip right over that line.
Okay, we can store data and we can tell the code what to do. But to build really big, complex things, you need to organize not just your data, but your code itself. This is where we start creating reusable blueprints.
Think about a task you have to do over and over again. A function is like writing down a recipe for that task. You define the steps one time, you give your recipe a name, and then anytime you need to do that thing, you just call out the recipe's name instead of rewriting all the steps. It's the ultimate work smart, not hard tool in programming.
Here's a perfect little example. We've built a function called get_formatted_name. It's designed to take in a first name and a last name. Inside its recipe, it combines them, formats them nicely, and then that return keyword sends the finished result back out. Now, we can use this little name formatting machine anywhere in our program, as many times as we want.
And now we get to one of the biggest, most powerful ideas in all of programming, the class. If a function is a recipe for a task, a class is a blueprint for a thing. A class lets you define what a car is, or what an alien is. It defines what information that thing should have and what it should be able to do.
For instance, here's our car blueprint. This set of instructions says that any car we create must have a make, a model, and a year. And from this one blueprint, we can now stamp out countless individual car objects. We can make a specific Audi, a specific Tesla. Each one is built from the same master plan, but has its own unique details.
So, how does this all come together? Let's bring it all the way back to that alien invasion game we talked about. Suddenly it all clicks into place, right? A variable is what holds the player's score. A list is what manages that whole fleet of aliens on the screen. If statements are running constantly, checking for collisions between your ship and an alien. Functions organize all the game's logic. And classes? Classes are the blueprints for your ship and for every single alien.
As you move forward, keep this quote in your back pocket. It's from something called the Zen of Python, which is like a set of guiding principles for the language. The point is, Python isn't just about getting the computer to do something. It's about finding the cleanest, clearest, and simplest way to do it. The goal is always to write code that's not just functional, but elegant.
We've gone from a single line of text all the way to the blueprints for creating entire digital worlds. You now have the map. You have the fundamental building blocks. The only question left is, what will you build?